Lesson 34, Public and Private Members. To follow along with this lesson, you will need to create a new console project and add a new file named main.cpp to it, as we did in Lesson 1. Our first program contains a simple class that represents squares. This class is a simple constructor, a member function to compute area, and a single data member to hold the length of the side of the square. In our main function, we initialize a square with side length 2. Then we print the side length and call the area function to print the area. Executing the program, we get this. Many times we will not want to expose every member of a class. To restrict access to members of our class, we make them private by putting the word private above them like this. This hides our side length data member so that it can only be accessed via member functions. Now we can try to execute the program and we get a compilation error in the line where we try to access the side directly. A member which is private can still be accessed by member functions, as we do in our area function. So if we take out the line that accesses the data member, we can compile and run the program. Here we show our class with the public part in white and the private part in gray. The public part which we can access is called the interface, and the use of private is a simple form of data hiding. In our next program, we use a class to represent a light with a dimmer switch. We have a simple constructor which takes a maximum and minimum value. Then we have two member functions, brighten and darken, which change the intensity value. We also have a member function which retrieves the intensity value. For data members, we have a minimum, maximum, and intensity value, all of which are private. Since the intensity can only be accessed through member functions, we can restrict its value to our specified range. To illustrate, look at our main function. We initialize a light that can take on values from 0 to 10. The intensity gets set to 0 by our constructor. Then we call our member functions and output the intensity value a few times. Executing the program, we see this. Notice that our first call to darken did not change the intensity value because it was already at the minimum, and our darken function stops working there. Looking at our class, we have multiple public and private members. Here we show the private region in gray. It is possible to have multiple public and private regions though, and we can specify them like this. This class is equivalent to the previous one, even though the members are rearranged. Here we show the private regions in gray. Notice that the top region before the first public label is in gray. This is because class members are private by default. For our final program, we have a class that holds an array of 4 ints and sorts them. We have a constructor and two public member functions, print and sort. The sort routine is a simple bubble sort. At the bottom of the class, we have a private member function named swap and our array of 4 ints. We use this program to illustrate that we can hide member functions just like data members. In this class, the swap function only gets called by the sort function. The purpose of hiding functions like this is to strip away the non-essentials and make the class easy to use. It is similar to the way an automatic transmission makes a car easier to drive by handling the shifting internally. In the main function, we instantiate the class with 4 integers. Then we print them, sort them, and print them again to show that they have been sorted. Executing the program, we get this. This concludes the lesson.